Video of 2020.
And you guys are part of that. Okay, kind of in the, maybe in the margins here, this investigation is stuff that we've talked about before. It is what's called transformations. We've talked about this since 5th grade or whatever it is. And there are 3 types of transformations. They would be, do you remember? They are the rotation, which is what? The old proverbial spin. They are a reflection, which is like the mirror image. And the easiest one of all is the translation, which is just sliding it to a new place. And there are some that are easier than others. We are starting off with the most difficult one because you kids are smart and difficult should not be in your vocabulary. Are you with me? Okay. So let's look at this. First one, this one says, I want to take this shape. Maybe we'll just color it in. Just because I like it. Well, maybe I shouldn't. Should I? Sometimes like to play with the colors. It says to take this shape, dear 7th grade, let's blow it up. It says to take that shape and rotate it about what? What's my rotation point? What's it say? 90. I'm rotating at 90 degrees about what point though? The origin. The origin, and the origin is right here. God bless you. Okay, which means, you know, if I could cut this piece out, put a pin right there, and take it and turn it a 1/4 of a turn, what would happen to this shape? Okay. Now it's hard to envision it. Some of you can see it better than others. Some of you have like a little more mathematical sort of thing here. But this is the best way to figure out where the new shape would end up. Okay, is this. Okay. Look at the axis. For example, this is the y-axis. If I were to take this y-axis and turn it a 1/4 of a turn, where would it end up? It would be the same place as the x-axis, right? So if you did that, this point L, it's even too big. This point L is still 1, 2, 3 spaces away from that, except it's on the x-axis. So point L is going to be 1, 2. This is my new point L. By the way, when you do in math, when you do like a point that coincides with another point, put a little apostrophe up there, it's called prime. So my new L prime is right there. Notice how this just spun 90 degrees, a 1/4 of a turn. So there's my L. Where would my Z end up? Again, the same thing. This is the x-axis. If you turn this axis 90 degrees, the x-axis actually becomes the y-axis. And how far is point Z away from that rotation point? 1, 2, 3, 4. So here at 1, 2, 3, 4 is going to be Z prime. So now I've got my 2 points, and you could probably connect those dots if you like. We still have to find that 3rd one, but let's connect it. What was it, orange? So I know I've got L connects to Z right here. Everybody good with that? Why not? It's kind of a thick thing here. How do I find letter J? Letter J or J prime, this is the toughest one to figure out. But I guess the easiest way to think about it is the same thing. Think about this being, you know, this axis being turned 25 degrees. Where is point J? From this point, you have to go over 2 and up 1, 2, 3, 4, 5. So if you spin that and go make this axis, I'm going to do the same thing. Over 2 and up 1, 2, 3, 4, 5. So that would be point J prime. And then you've got all of the points that you need. You can connect this with this and that with that. And that is your rotation around that origin thing. It's kind of tough to think about. I mean, it's a little on the challenging side, but if you just kind of, you could have also thought about it like this. from point Z, what do you do from point Z? You just move over 1 and up 3, or up 2. Here's over 1 and up 2. It still gets you to that point. There's a couple different ways to think about it. What's the next one you asked? Let's try another one. How about this one? What does this one say to do? Oh, translation. Watch how easy this one is. If you're just translating or moving, you just need to go 4 units right and 1 unit, is it up or down? 1 unit down. So to find the new point F, you just go 4 units right, 1, 2, 3, 4, and 1 unit down. So there's your F prime. 4 units right, 1, 2, 3, 4, and 1 unit down. There's your G prime. 4 units right, 1, 2, 3, 4, 1 unit down. And then you just connect your proverbial dots. Are they proverbial? What even does that mean? Connect, connect, and connect. So the whole thing was just slid 4 over, 1 down. Probably the easiest one. Rotation to me is by far, oh wait, no, reflection is probably harder. Sorry, is there a reflection on this?
Yeah.
Which one is it, 4? Let's do that one. This is one that always gives people issues. Okay? First of all, you have to figure out what is your reflection point? What does it say reflected about? The x-axis. Okay? So let's establish that reflection point. Here is your reflection point. This is what it's getting reflected on. Okay? And the thing to remember after you figure out the reflection point is you just think perpendicular to your reflection line and opposite direction. If you think those two things, this is actually not that bad. I'll let you write that down, and then I'll let you pause for a moment's reflecting on your favorite Christmas present, River, which was what? How many people got cell phones? Boo. iPhones? Boo. You're just supporting the man. River's not saying anything. Have you used it a lot, River? Do you find yourself glued to it like every moment of every day, that's your whole life revolves around it? Because you will eventually. That's just my personal. All right, so here we go. This is what this means. Let's look, if you're trying to find J prime, well, let's do K first. Let's do K first. Okay. See this point here? Here's my reflection line. Point K is exactly 1, 2, 3, 4 units away from my reflection line. Okay? It's also going to be 4 units away from the reflection line on my new shape, except it's going to be in the opposite direction. So instead of going 4 this way, to find my new K, I go 4, 1, 2, 3, 4, up, up. This was 4 down, so my new K will be 4 up. Okay? My M is how many units away from the reflection line? Just 2. It's 2 down, so my new point is going to be 2 up. That's my point M prime. Here's where things get, because this is so close to the reflection line. Point J is 1 unit up, so I have to go 1 unit down for my J prime. It's right here. And point C is 1 unit up, so I go same direction, same place, opposite. C prime is 1 unit down this way. And there you have the 4 points that you just need to connect for the reflection. Fascinating, isn't it? And if you don't take it apart piece by piece like we did, it's really hard to draw this without thinking about it that way. How come my stuff doesn't go where it needs to go? Let's see what else we got on this paper. I can tell you ready for it. Yeah. What does this one say? Oh, wait. Oh, describe the transformation. Hold on a second, I have to unlock this thing. Oh, great. Oh, I didn't even get the whole thing, did I? How bad. Which problem are we looking at? 5 and 6? Yes. Somebody help me. 5 and 6. It's a little hard to get back into it there, children. Whoa. There it is. So this one you are supposed to describe what the transformation is. So problem number 5. Is that a reflection, a translation, or a rotation? It is, Ephraim?
Translation.
It is a translation. It has just been slid. And what is the translation? If you were describing the movement, Charles, it is?
1 unit right.
Yep. 1 unit to the right. Ah, how about number 6? 6, Daniel, is a reflection. And if you had to describe what that reflection is, what is the line of reflection? Where is the line that would split those two shapes in half? Anybody want to tell me? Who wants to? Brady? What? It's reflected about here? No, I don't think that cuts them in half.
Oh,
It's a line parallel to the y-axis, but where is that line that's parallel to the y-axis? Where x is what? X would be what number?
let me make this bigger.
Where is the line of reflection? Here, let's do this. By the beauty of the board, I'm going to move it over, and you tell me where is it reflected. There, there, there. Oh, it is there. Why? Because that splits it right in half, and all the things are opposite sides of each other. So if you were telling me what the reflection point would be, it's reflected, and this is hard to understand too, where x equals 1, 2, 3. It's that line right here where x is 3, and then everything is flip-flopped over around that. Yeah? Is there something actually on this paper to do?
Yeah.
Ooh, I like, uh-oh. Find the coordinates of the vertices of each figure after the given transformation. Methinks that you'll probably spend most of your, well, let's just do 7, 8, 9, and 10. I think I have to give you a piece of graph paper to do 11, 12, 13, 14, but I don't want to overwhelm you right after Christmas break. Right, Charlie? You don't want to spend hours on homework tonight. You have TV shows to watch, don't you? Charlie, what do you do when you go home? Anything?
Do my homework and just play my PlayStation.
Oh, PlayStation. That's a whole different